In this video, we're going to go over Check Your Understanding 1.2b, which is number 53 from the textbook. So the title is Traveling to Work. How long do people travel each day to get to work? The following table gives the average travel times to work in minutes for workers in each state and the District of Columbia. So we have 51 values who are at least 16 years old and don't work at home. So this is one quantitative variable. You only have one variable, travel time. And we have decimals here, so it wouldn't make sense to represent this as a dot plot or a stem and leaf. So that's out of the picture. And it does say make a histogram of the travel times using classes or like bin width, you could call it either one, of 2 minutes, starting at 14 minutes. You could do this by hand, grab a ruler, sketch it out, count how many times you have values that are between 14 inclusive to 16 non-inclusive, but we have the technology and that's what we're practicing. So let's get that histogram on our calculator. So when you enter the data, stat, edit, I have everything in L1. I kept some old stuff in L2 just to show you. You can highlight L2 and press clear. So you can press clear and then enter and just get it to go away. Be careful not to press delete. I learned this the hard way in the first draft of the video. I pressed delete. If you accidentally delete it, notice how my L2 is gone. So if that ever happens to you, that stinks. But you can do second delete to insert and put L2 back. It's asking for a name, so I want to restore L2's rightful place. So I'm going to press second 2 to tell it to name that column L2, just in case you ever delete anything, because that's annoying. You don't want to just be resetting your calculator all the time. So I have these 51 values in L1. Don't worry about the state names or anything. I'm going to go to my stat plot and, make sure everything's off. I do want my stat plot 1 on. The type is a histogram. XList, I have all my data in L1. You don't want anything here. It doesn't let you leave it blank. And you don't want to put L1 there. You just want 1. That all the values in list 1, we only have them once. It's not like I had an average of 23.6 a couple different times. Each value represents itself. So you put frequency list 1. And let's do zoom stat just to get a good picture, although we are going to edit our window manually because it says exactly what it wants for the window. But I like to do zoom stat anyway to get it to adjust like the Y values. Okay, so I did zoom stat, it's looking good, but it wants me to have a specific window. Using classes of width 2 minutes. So that width is going to be the X scale, so I'm going to change that to 2. And we're going to go from 14, starting at 14 minutes, and then I guess I'll go to 34. Let's see what that looks like. So this is the window I'm using. And now I'll press graph. And there's your graph. So you could sketch that out to see the values. So I didn't have to count. All right, there were 2 values between 14 and 16. 4 values between 16 inclusive to 18. Let's see what our tallest is. Between 22 and 24 happened 14 times. So it's typical that the travel time to work is somewhere between 22 and 24 minutes. So let's continue on this. So we made a histogram. This is what your sketch should look like. Make sure you put a label. This left side is the frequency. It's counting how many times did a number occur within this interval. Now the second part says the shape of the distribution is a bit irregular. Yeah, it's not perfectly patterned. Is it closer to symmetric or skewed? Well, there's no clear skew here. Like most of our data kind of fell in the middle and then maybe another little bump, but imagine just kind of drawing a smooth curve over this. It's fairly symmetrical. Describe the center. So I can just kind of visualize the center being about here. And when distributions are symmetrical, the center will be kind of the same as the median, like the mean and the median will be kind of similar, which would be about there. And there doesn't look like there's any outliers. And the spread, right, we go from 14 to 32. From this picture, we can get the exact values on the data set, but here's a formal answer. The center of this distribution of travel times is approximately at 23 minutes. I went ahead and used my calculator to figure out exactly what it is. You didn't need to do this, but the mean of the distribution is 23.1 minutes, and that's close to the median of 23.4 minutes. I underline minutes here because that's just me establishing context. You should never say is approximately at 23. We want to know what you're talking about. 23 what? And I added that this closeness supports that the distribution is closer to being symmetrical than skewed, because that's going to be true when there's symmetry, that the median and the mean will be close. The distribution has a range of 15.4 minutes. So I went and I did the max minus the min. I saw in an answer key, it said you have values from 14 to 32. Just make sure you don't say it has a range of 14 to 32, because remember, range is one value. And there do not appear to be any outliers. So I hope your calculator worked and everything was good. And see you on the flip side. Great ending.